Greetings everyone. Welcome to my YouTube channel. Today, guys, I want to take you through the data science project where I will be performing a project using Python language. Ladies and gentlemen, without wasting time, let me share the Python notebook. Here it's my Python notebook, ladies and gentlemen. I'm using my local machine to do the analysis. This was just an internship. It was an internship which was provided by Wixflux Technologies. According to the title of the project, like the main aim was to analyze the customer churn prediction in a telecom company. And ladies and gentlemen, I will go through the project. I've used Python to analyze the data set. Python is one of the programming languages which is very versatile, and it's a general purpose type of programming languages where it can be used in different fields like web scraping, in the field of engineering, in statistics, and in most of the fields. This is one of the programming languages that can be used like Java and the R. Right, without wasting time, ladies and gentlemen, I want to take you through the project. According to the project statement, this is about the telecom company. Telecom company is actually interested in exploring what is called a customer churning, right? Which I will explain it. Customer churning, which is also known as the customer attrition, and this refers to the loss of customers over a time. When customers in a specific company fails not to come back again. This is one of the aspects that we want to look at. This phenomenon has significant applications for business across various industries. Now, by exploring, we need to explore the advantages and the disadvantages of customer churning, which are actually the pros and the cons. Right, the disadvantages are as follows. Customer churning can lead to loss of customers, means by losing revenue streams associated with those companies. For example, let's say in a company you had roughly 500 customers who are actually buying at your company. Obvious, if they start to do what? To churn, then it means the revenue at your company is actually dropping because of those customers who are no longer working with the company. And again, regularly acquiring new customers can be costly and time consuming, which is true. High churn rates may include poor product quality or service issues. Negative word of mouth can deter potential new customers, especially like if you're not servicing well your customers, if you're not responding well to your customers, that might lead to a challenge. And again, it might increase marketing costs. And to replace lost customers, companies often need to invest more in marketing efforts. So it means they have to heavily take some of their money and invest into marketing in order to attract other customers. And acquiring new customers typically cost more than retaining existing ones, which is important because now it means you'll have to market them. They're not used to your system, and you need to come up with good strategy to welcome them. Long-term customers often accumulate valuable data and insight. Losing these customers means losing access to their valuable information. Frequent customers turnover the turnover can also describe business operation and the process. It may lead to an increased support tickets and reduced efficiency, which is true because this customers churning has a significant impact in the production of the company. Right. Also taking into account the issue of profit or the net profit in the company or the revenue. This also should be taken into consideration. Right. And again, the advantages, which is the pros, is the issue of that churning can also prompt customers, I'm saying companies, to release their product or services. It may lead to innovation and improvement based on the customer feedback, and also analyzing customer patterns. Churn pattern can help identify high value customers segment. Companies that successfully reduce churn rate may gain an edge over their competitors. Low churn rate can attract investors and improve stock performance. For example, if someone wants to invest in your company, can also look at the issue of the churn rates. And if it's very low, then that person might be interested in investing in that company, because the issue of revenue, knowing that it will keep on going up. Then again, identifying reasons for churning can help allocate resources more efficiently. Companies may focus on improving areas that contribute most to churning, which is one of the advantages of customer churning. Right, ladies and gentlemen, in this data is actually available on Kaggle. The company has provided a data set with information on customer demographics, services subscribed to, usage pattern, and other things, which is also available on Kaggle. You can visit www.kaggle, or you can just say on the internet, then you just type Kaggle, then you go through it, then you'll be able to get the available data set. All right. Without wasting time, I want to talk about the objective of this project. The aim of the project actually is to develop a model to predict, whether customers will stop using the service based on the historical data or not. So it means we want to make prediction whether they will stop using or they will not stop using. And remember, this is an example of a classification type of a model, where in terms of classification, it's actually dealing with binary outcomes. For example, if you want to test for yes or no, if someone has passed or not passed. So this is an example of a classification data set. So which we'll talk about that. Then again, we'll use a classification technique, like I just said now, and also use other future engineering to actually improve the model accuracy, which I'm going to talk about the issue of accuracy later. Then we are going to also visualize the key factors that are contributing to churning. What are the factors that actually lead to the process of churning in a company? And in that regard, we'll now move on to the data description. Right, in terms of the data description, with this actually explaining more about the available data. What are the features in the data? Right, in the available data for Telecom Company, these are the columns that we'll be talking about. Number one, we have what we call the customer ID, which is a unique ID that identifies each customer. And also it will look at the gender, which is the customer's gender, whether it's a male or a female, the age, customer's current age, and yes. Married, indicate if the customer is married or not. Number of dependents, it shows the number of dependents that lives with the customer. It could be a child, it could be a parent or grandparent, and so forth. It also indicates the city in which the customer is residing. Particularly, this is the data in California. All right, this is I think it's a USA data set. Then also it shows the zip code, which is the zip code of the customer's primary residence. latitude, which is the customer's primary residence in terms of its latitude and longitude, and also the issue of the number of referrals, which is indicate the number of times the customer has referred a friend or a family member to come and take part in the company. Tenure in months, what is this? It indicates the total amount of months that the customer has been with the company by the end of a quarter, specify above. Then what is the offer here? Offer identifies the last marketing offer that the customer accepted. None of it offered A, offer B, or offer C, offer D, and so forth. And again, phone services indicate if the customer is subscribed to home phone services with the company for yes or no. Average monthly long distance charges. This has to do with it, indicate the average long distance charges calculated to the end of the quarter specified. If the customer is not subscribed to home phone services, then this will be 0. Then another thing is the multiple lines, which indicate if the customer subscribed to multiple telephone lines with the company, either yes or no. If the customer is not subscribed to the home phone, then this will be no. Because if it's not subscribed, then there will be no any multiple lines that he or she has taken. Then again, the issue of the internet service, which indicate if the customer is subscribed to the internet services with the company, either yes or no. And also the type of the internet, what type of an internet the customer has connected to. It's either a DSL or a fiber optic or a cable. But if the customer is not subscribed to the internet, then this will be none. Again, now the average monthly gigabyte downloads, which indicate the customer's average download volume in gigabytes, calculated to the end of the quarter specified above. But however, if there's not any subscribe, then this will be 0. And the online service, the online security, which indicates if the customer is subscribed to any additional online service provided by the company, yes or no. And again, online backup indicate if the customer has subscribed to any backup of online services provided by the company. And the device protection plan indicate if the company is subscribed to any additional protection plan, premium tech supported, whether the customer is subscribed to any technical support, streaming TV, whether the customer like uses internet services to stream the television programming from a third party provider at no fee. Then again, then the other one, moving on, is the issue of streaming movies, streaming music, unlimited data. This has to do with whether customer is paid to any additional monthly fee to have unlimited data downloads or uploads. Then again, the issue of contacts, which indicate the customer's current contact type, whether it is on a month-to-month, whether it's a 1-2 year, or it's a 1 year or 2 year, according to the customer. Paperless billing. This indicates if the customer has chosen any paperless billing, whether it's yes or no. Permanent method, payment method. This indicates how the customers pay their bills, whether it's a bank withdrawal, whether they were using credit cards, or whether they were using mailed check. Then also the issue of monthly check indicate the customer's current total monthly charges for their services from the company, total charges which indicate the customer's total charges, which is actually calculated to the end of the quarter. Then total refund, this indicates the total refund calculated to the quarter specified. Total extra charges, this is just an extra charges for downloading above those specified in their plans. Total distance charges, and again, I just want to check something. Okay, and again is the issue of total revenue. Total revenue, this one, it indicates the total revenue from the customer, calculated to the end of the quarter specified. And this total revenue is actually calculated by taking total cost minus total refunds plus the additional cost plus the total distance charges, which is actually originating from the other parts. Then also is the issue of customer churn status. And this, it indicates whether the status of the customer at the end of the quarter, whether they've churned or they've stayed or they just joined the company. So these are the status. So it means we will be giving 3 types of customer status. Either they've changed, or they have stayed, or they just joined the company. So it's 3. This is an example of a multi-classification, which we'll talk about, ladies and gentlemen. And again, we have what is called the churn category. It's just a high-level category for the customers' reasoning of churning. What is their possible reason of churning, which is asked when they leave the company. So it's either is it the issue of the company, the attitude, or the competitors, or the dissatisfaction, or it's other thing, or it's just the issue of price. And this is very important for the company to be able to know, like in terms of their churning status, where can they make improvement. Because if it's the issue of the attitude or the competitors, then they have to come up with a marketing strategy to improve that. And again, is the issue of churn reason. What is their churn reason? Actually, a customer-specific reason of leaving the company, which is asked when they leave the company. I think this is related to the churn category. So what is the reason of the customers to actually leave? To actually do the churning, as I mentioned, the issue of the advantages and the disadvantages. All right, since now I went through the data descriptions, which we will be seeing these columns in the next part, I want to import the libraries. First of all, before I import the library, I need to explain what are the functions of these libraries. Number 1, we have libraries that are responsible for data reading and manipulation. And one of the library is called pandas. Pandas, it's one of the most important library in Python. This library is actually used for data reading. For example, if you want to read a data as a CSV file or as an Excel document, we usually use these pandas to read a data frame. Then again, for manipulation of data, we have something called NumPy. So NumPy, it's a numerical Python library, which it is just a mathematical library which we use actually to do with data manipulation. For example, if you want to calculate the mean of a data, if you want to calculate the standard deviation, if you want to, like, those things, we actually use a NumPy array. It has to do with, it is to do with mathematics and statistics and other aspects, right? Then these are the first libraries that we're going to import. So we're going to import pandas as PD and also import NumPy as NP. So, right, each time it means if you want to use pandas, you just say PD dot. So if you want to use NumPy, we're going to use NP dot. So let's say we want to read this as a so it will be PD dot read. Then we specify the type of the data, the type of the file that we actually want to read. So this is called the pandas data frame. Right, then for visualization of data, we'll be visualizing data in this project. So we'll be using libraries like matplotlib, and the Seaborn. These are the libraries that are used to do with data visualization. For example, if you want to draw a pie chart, if you want to draw a box plot, we are going to use this. So these are very important in Python, ladies and gentlemen. And again, since we are going to build the models here, and remember, this is an example of a classification technique. So we'll be importing some other models which are relevant to classification, because this is an example of a supervised learning technique. Yes, this one is a supervised learning technique, like is like regression. Regression is an example of a supervised learning technique. Right, under this, ladies and gentlemen, again, here we'll just import the metrics, which we'll talk. The first one is the mean absolute error. This is the mean absolute error. This has to do with the minimizing the errors by using an absolute value. And again, actually, this is the mean from the true value and the estimated one divided by n. We'll talk about this. And also, we need to import what we call the F1 score, which I'll talk about. This is actually the performance matrix for classification, accuracy, recall, precision, and the ROC, which we'll talk about, area under the curve score. Then again, we need to also import from sklearn. Actually, the Python uses a library called sklearn to import the model. Like actually, when we want to import the issue of that is to do with metrics. When we want to tune models, actually we use the sklearn. And again, we're also going to say from sklearn model, we need to select the model for train test split. It means we're going to split the data into train and testing, which is this is a good practice when we are analyzing data, to avoid something called data leakage, to avoid what is called the data leakage, and also to reduce things like to reduce overfitting and underfitting, which I'll talk about this in the next part. So now, again, we also have to use what you call the cross value score, which we'll talk about that. And we need to also come up with what you call for data scaling. We'll be scaling the data. Actually, we call it the normalization of the data. And this is it's one of the good practice when you are analyzing data. Then we will import what you call the standard scaler, and also what is called the one hot encoder. The one hot encoder, this is actually used for labeling. For example, if we have, like, say we have a data that has like it has a categorical items. For example, let's say we have things like in the customer status, we spoke about churned, stayed, and what is this, joined. So already in the model, when we're going to predict, the model actually does not allow categorical data, which means we need to convert these to the numerical. So we can say, maybe according to, we say, when we say churned is 0, not churned it's 1, joined is 2. So we just provide numbers into these items. This is an example of a one-hot encoder. And then again, we will be dealing with what is the chi-squared method, the chi-squared technique. This chi-squared technique, it's used for what you call categorical selection, feature selection. So this is just a way where we'll be talking about, like, there are some features which are necessary to be used when you're making prediction. So we use this chi-squared method to do away with some of the features, the redundant features. And again, we'll use what you call the oversampled and the undersampled. This is to do with the imbalanced data. You find that we have a data where we are comparing, let's say, in terms of the status of churned, those who churned and those not churned. For example, you find that it's only 40 who churned, but only 20 did not churn. You see, this is actually an example of an imbalanced data. So we need to come up with a strategy to deal with imbalanced data, because if we are just not addressing this, you find that when we make prediction, it will favor the one side in compared to another. So these are the models. I mean, say these are the techniques that we'll be using that is to do with imbalanced data. Then again, we'll be dealing with what is called the hyper-parametric tuning. Actually, the tuning is done when we have modeled, like when we predicted and we found, we look at the performance of the model, but only to find that the model is not well performing, then we have to come up with something called hyper-parametric tuning, like at least to try to reduce what we call the overfitting or the underfitting in the model. So we have what you call the grid search and the random search. Actually, in terms of the grid search, this one takes time to perform the model selection as compared to the randomized search CV. Then again, we'll have to define the maximum number of columns that has to be displayed in the data set. This is just a good practice when we are analyzing data. And also, we're going to actually import some ensemble models which will be using to do the analysis. And this ensemble models were what you call the random forest classifier and the Bayesian classifier. Then again, we'll import, okay, I apologize here. We'll just try to suppress the notation so that whatever we're going to display, usually it must be rounded to 3 decimal places. And also we come up as a good practice, we need to make sure that we suppress the warning. Like when we are doing the running, if there is any unnecessary warning, then we just requesting the Jupyter notebook not to display that warning. Now, right, let's start with our analysis. Ladies and gentlemen, since I'm using my local machine, so it means we will not be using what you call the Google Colab. Google Colab is just an online platform for dealing with data analysis, but it is being implemented by Google, and this is one of the efficient way, especially when we are dealing with data science. But however, since I'm using my local machine, I'll just comment on this data. Then I will just use the shorter way. Right, oh, okay, I apologize. Okay, it's fine. Let's just do this. Okay, one other thing that I want to explain is that Python is one of the programming languages that is actually case sensitive. So for example, if you are, let's say you want to write something, let's say you say data, then at the end when you want to print that, then maybe one letter becomes a capital, then you say data. Then by so doing, the Python is very sensitive when it comes to this, so we must be careful when we are typing. Right, then now here we're going to just to read the data set. The data set is the Telecom data set. We're going to read it as the pandas. Let me just do the function. It says, okay, let's just say we have a data frame, we just call it df. Then we're gonna say pd.read. So it means now this is just a function to call Panda to say, now I want to read, but what type of a file I want to read. So if I want to read a CS file, it means it will be an underscore CSV file. Then inside, then I have to call the path, the file path of that data. So let me just say here, I'll just say my file path equals to, and then it means here, let me just do away with the quotation marks. All right, then now the file path, let me go and take the file path. Okay, just a minute. Okay, there is the file path. Let me just go. What is this? This is customer chaining data set. Telecom, that is, then I'm going to say copy file, then go back to my data, then here I'm going to paste the file here. So you see this, it shows that we have a Telecom customer chain. It's a CSV file, which I supposed to have opened it earlier, but I can even, instead, if I don't want to create this file here, I can also put it inside here. Rather than creating it there's no problem. I can also put it, but it must be in quotation marks. Right, we can still do this. So now it means here it shows that the file now, it can be able to call this if I'm putting it inside the quotation mark. So let's now run the data, the data frame. If I run it, then, oh, I apologize, I should have started running the first libraries that are important. I imported there. It says PD is not defined. Yes, it's not defined because I did not run the first one. So let's now run the first libraries. I need to import it first so that it can be able to respond in terms of the reading. So yeah, I just want to read the CSV file. Right. While waiting, let's just check something here. Because here it says pd.readsv file says pd is not defined. So it's able to tell me that something's wrong. So it means I need to make sure that this pandas is defined. So when we check here, it's still running. It is still running all the libraries. It's still importing all the libraries in order for me to use them in order to do the analysis, ladies and gentlemen. Okay, we'll just wait a minute. I think it will be done soon. I'm just using my local machine, ladies and gentlemen. Remember, Python is very versatile. You can go through it, and if you want to learn more about it, you can check online, like the Python for beginners. Then you'll be able to understand. This one of the easiest. Right. Let's now read the data. Now we are going to read the data. Now you see, now it's no longer showing the error. So let's check on the first part. It says we need to code to print the first 5 rows. Right. When we want to print to display the first 5 rows, we use something called head. We use data.head. So if we just come up with our data frame, we say the data.head, then it must be in brackets. So this will always display the first 5. But if I put any number, let's say I put 10, then it will display the first 10 rows of the column. So, but now since we want to just to display the first 5, that means we'll just say df, it's our data frame. It is our data frame there. So that's our data frame. So I'm going to say df dot. So, okay, I apologize. So let's just say df dot. If I say df dot head, then in brackets, then if I run this, it will display the first 5 rows of the data. You can easily see here's the data. The first column is the customer ID. Second one is the gender, the age, married, number of dependents, city, zip code, latitude, longitude, the number of referrals, and so on. We can even check up until the last, the issue of streaming movies, paperless billing, customer status, whether stayed, churned, customer categories. But if you can check here under the customer category, some of the data, the null values. So it means they're not available. It's just the null values. So we need to be able to deal with the missing values. It shows that this data set, somehow it has the missing values. Because you can easily see that here we have something like the null. These are the null values. It shows that some of the columns has missing values. So which we will have to check that, ladies and gentlemen. Right, how about if we just want to print the last 5 rows? Here it says code to print the last 5 rows. We're going to do the same, but this time around we use tail, df.tail, to actually display the last 5 rows. So df.tail, the df.tail will show only the last 5 rows of the data. Then now we can also look at with data type, what, like in terms of how many columns are here and how many rows are there. To do that, we can say df.shape. We use a function called shape, not in brackets. df.shape will tell us the number of rows and columns which are here. You see, we have 7,043 columns, rows, and 38 columns. And we can also do a display using what you call the f-spring. So inside here, I can say, if I say df.shape, then in the close brackets, like then if I say 0, it means now I want the rows. But if I say df.shape, then now I put 1, then now I want the column. So if I print this, then it will tell me that the telecom data set consists of 7,043 rows and 38 columns. Already it means we know the type of the data set here. Then again, we can check if the data type of the data type, whether we're dealing with numerical columns or categorical column or so forth. Because in terms of the data type of, in terms of Python, it can be either the integers, it can either be a float, or it can be either be an object data or a categorical data, which is an example of strings actually. And also we have other type which is called the Boolean. It's also another type, also has to do with complex numbers, but generally we talk about the integers, float, and the object. So let's check the data types of this telecom data set. So I'm going to say df.info in brackets. Let's run this. So you'll see that it shows that we have the customer ID. It's an object data type. Gender already, because it's an object, it's string data because it's male or female. Age is an integer. Married, it's an object because this has to do with whether a customer is married or not. The number of dependents, the zip code. Some of these data or some of these columns, guys, are unnecessary if you want to do the analysis to check the chaining, actually doing prediction. For example, things like customer ID, these are unique items which we can remove them. For example, the zip code, we can still remove them in the data set because they're not important for doing the analysis. Right, but in the meantime, let's just proceed. Then when you look, you see that it says here at the bottom, the D type, which is, it has floating 64 of 9 of them, the integer 64, it's 6, and the object, it's 23. You can add, you see that all in all there, 38. So this is what I just said now. Now, let's now display the statistical summary of the numerical data set. We want to deep dive into the issue of looking at the distribution of the data. And to actually display the statistical summary of the numerical column, we use something called, we use the data frame dot describe. We use what you call describe. But if I just do it, let's say I say df.describe, it will show the columns, the numerical columns as in a column format. But if I want them to be if I want this column not to be in a, this column not to be in a row form, I want them to be in a row format, to be this side, then I will have to use something called transpose. I will have to transpose them. So to do that, it means in the same function there, what I'm gonna do, I'll just say dot transpose. So I want to transpose the column so that I can see them easily. So now that is our information. You see that here, it's actually this is a statistical summary of the numerical columns only. If you can just look at this, guys, here it's counting that how many observation of ages or how many years of ages are we having. So it's 7,043. Then what is the average? So this has to do with the mean. So what is the average of the ages and what is the standard deviation? And also what is the mean, the quartile 1, the quartile 2, the quartile 3, and the maximum. This has to do with 5-number summaries. The one that we use to construct a box and whisker plot usually is the one that we use to construct a box and whisker plot, because this is the minimum, the quartile 1, which is the 25th percentile. Then this is the 50th percentile, and this is the 75th percentile, and this becomes the maximum. So you see that by looking at this, we can be able to comment on the distribution. For example, if you look at let's say we want to talk about the tenure in months. So if we compare this, let's look at the mean. The mean is 32.8 4, whereas the median, which is quartile 2, it's 29. So you can see that the mean is actually bigger than the median. And we know that when the mean is bigger than the median, it means if we construct a box and whiskers diagram, then here it will be Q1, then they will have Q2, and there it will have Q3. So it means the average will be somewhere here. So that the average will be bigger than the median, which means this is skewed to the right. So it's skewed to the right distribution. So we're dealing with a skewed to the right. For example, again, if we look at the monthly charges, the mean for the monthly charges is 64, whereas the median is 70. You see that the mean is smaller than the median. And we know that when the mean is a value smaller than the median, it shows that this is skewed to the left, or it is negatively skewed to the left distribution. So it's very important to be able to look at this. So this is what I was just trying to display in terms of the statistical summary, ladies and gentlemen. We're still going to see this when we're going to compute some of the, like to display some columns, numerical columns in using a box and whisker diagrams, or what you call the box plot. All right, let's now continue. For example, if you look at the total revenue, which is very important, the customer's total revenue here, it ranges from, as a minimum. What is the minimum here? The minimum is 21,000, I'm saying 21.36 to a maximum of 11,979.34. I don't know, it might be in US dollars. So, right, which means that let's look at the mean. What is the average? What is the average for the total customer revenue here? So when we look at this, we can see that, for example, the mean is around 3,034, whereas the median is around 22,108. So you see that the mean, it's actually bigger than the median, which shows that this is skewed to the right. So these are the things that you need to consider when you are analyzing the data set, ladies and gentlemen. Right, then now from here, we must also be able to, like, if you can just check, like in terms of what I commented, I said the total revenues data exhibit a skewed to the right distribution with the mean that is bigger than the median. And also we can say, if you look at this, 75% of the customers have a monthly turnover of 75 of just from 55 and below. All right, again, here we can just look at, let's say we want to check if there's any missing values. We're going to say df.is null, the is null the sum. So we want to check if there's any missing values here. So when we print, it will show the columns that you see. It shows that there's some columns, like the offer column has missing values. The monthly average, it still have missing values. But let's say I wanted to know in total how many missing values. So it means I have to also add some again there. Then it will tell me that I have how many missing. But you see, all in all, I have 30,844 missing value in the data set. Okay, let's now check for the duplicates in the data set. Now we're going to say df.duplicated. This is a function to check for any duplicates. Then let's just sum them. Then this is just a function to tell us whether there are any duplicates or not. Then we're going to run. Just a minute. There are no duplicates in the data set. Now it means we can now move on. Right. The next part is the EDA, which is called the exploratory data analysis. This has to do with visualization. So we'll be visualizing here. We'll be dealing with the EDA, where we'll be dealing with data visualization. Particularly, I will start with the numerical columns only, but for a univariate, which means for one variable analysis. Then after we'll move on to the bivariate, also in terms of numerical and categorical. First of all, here it's a function. This is a function to only select the numerical columns only. So it's df.select underscore d types. Here it's indicating the types. But now we only need the numbers, not the categorical dot columns. So this is just a function to select the numerical columns only, right? If you wanted to select the categorical, it means where there is a number, we'll just put the object. So this will only select. So, but here it's a function that is used to select the numerical columns only. Let's just run. By running this will give us the numerical column. Let's say I wanted to display what are those numerical columns. I can write them as a list, or I can list them, but it's not a problem. I can also say numerical dot columns. Then this will show all the numerical columns. You see, we have the age, the number of dependents, zip codes, latitudes, and total. So let's say I wanted to list them. If I wanted to list them, then I'm gonna use this to say list these numerical columns, right? It will still display the same, but as a list. You see, it's showing that now it's listing as the numerical column, which is the age. And I think I'll also create a video to talk more about the dictionaries and the list. The list also can be indexed by using, like, for example, this, the index 0, the 1, the 2, the 3, the 4. So let's say I wanted to show for age only. So I'll just say list for that age. So I'll just say for the index of 0, I wanted that of 0 first. So this will just show the age only. So, but it has listed it as like it is categorized, like it has splitted the age into the indices. Right, but now if I say the list all, then this will actually display all the numerical columns. Right, within these numerical columns, ladies and gentlemen, as I said, columns like the zip codes, what is the other? Yes, especially the zip code, this need to be taken out, because it's not necessary for it to use it for analysis. Right, then now to make sure that I have safe information, I will first make a copy. So let's create a copy of the original data. So the function that we use in Python to create a copy is just .copy. So if we say df.copy, this will actually copy the original data. So if we say df.copy, so it means this will actually copy the data frame, maybe assigned to another different kind of a data frame. Here we call it data. So by so doing, it means now we're just making a copy of the original data source set, so that when we make changes, we don't change from the original data. So df.copy, already we have made a copy. Now we'll create a function to drop those unnecessary columns that I said. Right, there's a function in Python which is used to drop. This actually is a function that we use to drop the unnecessary columns. But if I say here data equals to data dot drop into columns, here I'm actually specifying the columns that I wanted to drop here. So since I said the columns like the zip code and the customer ID, these are unnecessary columns which you need to remove them. So here I will specify them as a list. We'll talk more about this. I'm going to specify them as a list to say I'm listing the zip code and the customer ID, but we need to drop them as x is equals to 1. When I say as x is equals to 1, it means we drop them by column. So we remove all the column. But if I say x equals to 0, it means we're going to drop by the rows. So, but to play safe, we're going to drop them by the column. So when we say x is equals to 1, it means it's going to drop those columns. Let me say, yes, those are necessary columns by the column part, not by the rows. So it means to drop the entire column of the zip code and the column, the customer ID. Then now it means now we're going to do this. Let's say, let's run it. In running it, let's say we wanted to check if the information is still the same. So we're going to say df the head. We want to print the first 5 rows of the data. Obvious, the first 5 rows of the data, you can easily see that we no longer have the zip code and we no longer have the customer ID. So again, we can also check the shape of the data. I think now it will tell us that 2 rows are already, say 2 columns are removed. The data shape, you see that it shows that from those 38 columns, only 36 are left. Why? Because we dropped those 2 columns in the data set that are necessary columns in order to do the analysis. Right, we can now proceed. Right, here what I've done is I've created a function. This function is just a function to plot a box plot and also a histogram at the same time for all the numerical column. Let me just explain it. Actually, in Python, when one is defining a function, you have to always use the function define. And from there, you specify the function, the name of the function that you want to define. Then in brackets, you need to put the arguments. What are the arguments that you're going to use in the function? Then with the semicolon, then you start writing all the function. For example, let's say I wanted to say, okay, it is just an example. Let's say I wanted to calculate the area. So I'll say in terms of the area, let's say our area of a circle, it's pi r squared. Then what we're going to do, we're going to say, okay, fine. We want to calculate the area considering different values of the radius. By so doing, it means now, let me just create something here so that I can just explain it thoroughly. So before I start doing this, let's say I wanted to calculate the area, but using the different functions. So in Python, we're going to create something like, if we're going to define a function, use the function def, and we call this, okay, let's just call it an area. But inside this area, we need to specify what are the parameters of the function. Obviously, this area is a function of pi and also a radius. So I'll just write radius. So it's a function of radius and also it's a function of pi. But I can just say, let this pi, in order to specify, we can just say the pi, it's always 3,14. Already I've specified the pi. I don't want it to change. So now then I will say, okay, fine. If I wanted to calculate the area, I will just say, okay, fine. I'll just say the value of the area. So let's just say area value. I'm now defining a function. This will be, what will be the area? The area will be pi multiplied by the radius. And in Python, if you want to say to the power, then we use doubles this sign. So it's going to be times. This is the power of 2. Then I will say return that area value. So now, if I say return area value, let's say I call this, you see, it will show that the function is already created. So, but if I wanted to calculate, let's say I wanted to calculate calculate the area when radius, let's say when r equals to 20 centimeter, then I'll just call that function. So I'll just say the area. By so doing, then I'll say the area of, okay, let's just say I wanted to say, okay, let's say I wanted to calculate the value. Let's say the value will be the area that I've defined. what is my radius? My radius is, let's say 20. Already there's no need to put the pi. So if I do this, then I run it. Then if I say, what is the value? Let's say print the value. It will tell me that the area is how much. Let's check. It says that the area is 1,256. And it's true, because if you do this, let's say with that pi, 3.14 times 20 times another 20. We just want to do it manually. So you'll see that will say it's 1,250. So it's just a function that is used in Python, which we actually use it to compute other, like to get different output. For example, if I change this, let's say I wanted to calculate when the area is 40. Obviously, it will be doubled of that amount. So if I do the calculation, okay, then it will now be 5,024. So if I do it again manual, again 40 by another 40, this will show that the area is the same. So this is just a function that we use in Python to say, whenever you want to come up with a function, you use the parameter def, then you specify whatever you want to do with your radius and your pi, depending on the function that you are looking for. So it depends with the function that you are looking. You can come up with any. So what I've done is that, okay, fine. Since here I wanted to display, actually I want to create a function that will display the histogram and the box plot for those numerical columns that I just specified. So what I'm going to do, I'm going to say def dot, then I'm going to call this a box with the hist plot. Then here is the data that show that I want to show the data, and also the item. The item, it has to do with my numerical items that I specified. Then here there's PLT. PLT is just a matplot function. Remember we said from the importing, we said import matplot lib.pyplot. Then we take it as PLT. So if I run this function of PLT, this has to do with, when I say PLT.figure, it will tell me that I have to specify the type of the figure that I need to display. Here I wanted it to just to set the size to be 10 by 3, and also the title, also specify the title. So it will be PLT.title, PLT.xlabeled, PLT. It means this will specify that on whatever the structure I need to provide. For example, if I want to do a histogram, it will label the y-axis, and it will also label the x-axis, and it will also provide a title on that plot. So, and also the size. So if I say plt.figure, it will specify the size, plt.title.xlabel.ylabel. So it means on the y-axis, I want it to display the frequency for the histogram. On the x labeled means it will be that item. So if I'm talking about, like, for example, total revenue, it will show that I'm talking about total revenue and its frequency. Then it will plot the histogram. And again, I will also use what you call the cbond. Cbond function, I can use it to do the hist plot. So this is the function to say data equals data, x is the item, KDE, it says on your histogram, do you want the pi, you want the function to draw the line along along that histogram. So I said KDE should be false, so that it must not show the line. But if I take it to be true, it will display the frequency curve there. So again, here is just say the x, here it is just showing that where we need to show the vertical line that will represent the mean by using a black and with dash, and also vertical line that will represent the median. So this is just a function to calculate the mean and the median, and show if it's a mean, it should be in black. If it's a median, it should be in red using the dotted line. So plt.show, it will show almost everything there. Again, whatever I've done there, I'll also do it for the box plot. But for the box plot, you have to show, like here I've done from the SNN or the cbond function. If you just to go online, you say SNS dot box plot, it will show all the features that are needed in order to plot this. Then I've also done the same. So this is just a function which I wanted to do rather than sketching I'm saying doing one column at a time. So this is the best way. So we'll just run the function here. Let's just run the function so that we can see it. If I run my function here, then we're gonna have something like this. From the function now, then again, I will have to select those numerical. But already since I have selected the numerical, then it means there's no need for me to rerun this again because it will still show the same, but it's okay. Let's just do it now. Then it says here, let's display the numerical columns of the data as a list. So we're gonna say list. So I want to display them as a list. You can also use print function. There's no problem with that. Control copy. So we'll just, okay, fine, let's run. If we run this, then it will show us that the numerical columns is this one. But now, what if I wanted to just to draw the box and Easter plot for just customer tenure in months, just for this numerical column rather than doing for all? So if I wanted to analyze this only, the customer tenure in months, so I'll just say from the same function, let me just go back so that you can understand. Remember I said now we are calling that function, we are calling our function. Here it's our function, now I'm calling a function to say, I'm calling these boxes, the data and the item. Remember the item is that numerical. So it means now we're gonna say, okay, fine. When I call this function, it will be box is plot, then the data is the data, the whole data we have. Then I need to specify the item that I wanted to display. So here it will be the tenure in months. So there it is. Let's run this. If we run this, it will show the box plot and the histogram for the tenure in months with all the labels showing the mean and the median, particularly on the box. I'm saying on the histogram or the hist plot. It will just take some time. Let's just wait a minute. And again, while secondly, we'll have to display, okay, there it is. You can easily see that, remember we said the black one is the median and the black is the mean and the red is the median. So you can easily see that from the box, from the histogram here, it shows that the mean is bigger than the median. The mean is actually bigger than the median. There is the mean and there is the median. So it means our data, the tenure in months has a mean which is greater than the median, which is an example of skewed to the right distribution. But still we can see this on the box plot. Let's now move on to the box plot. If you look on the box plot, you can easily see that from the box plot, more spaces is on the right. And you can easily see that on the box, this is the mean and this is the median. So you see that this is the left and the right and more spaces on the right. So it shows that they skewed to the right. We have a skewed to the right distribution. So which will also use it to do the analysis later. All right. Let's now continue, ladies and gentlemen. Let's also look at the box plot and the histogram for monthly charges. Rather than looking at all the columns, I'll just display for the monthly. For the monthly charges, you can easily see that the mean now it's less than the median. The mean is now below the median. You can easily see from the box plot that the mean is below the median. Remember that function I said, what I've done there is to just specify to label everything, to label the y-axis, the x-axis, also to give a title. Remember, when you are doing this, you are doing visualization, your graphs must not be misleading. So you can easily see that when you look at this is the median and this is the mean. You see that the mean it's less than the median. And we know that when the mean is below the median, it means the monthly charges are skewed to the left. They are skewed to the left with the mean less than the median. So that is what you need to know. And we can also look at see it on the box plot. You can easily see that the data is skewed to the left. Right. Again, we can move on and look at the box plot for the total revenue, customers' total revenue. So when we display this, then here we have the result. Here the result, you can easily see that from the histogram, even if we do not show the mean and the median, if we withdraw the KED or withdraw the line here, you can easily see that this data is skewed to the right. It is skewed to the right with the mean greater than the median. The mean is bigger than the median, ladies and gentlemen. Here's the mean and here's the median. By the way, if we draw the KDE, you can easily see that this data has a fatter tail on the right. It has a fatter tail on the right. And we know when a data has fatter tail on the right is the same as when we say it is skewed to the right. It has a skewed to the right or positively skewed distribution. So skewed to the right, ladies and gentlemen, because the mean is bigger than the median. So by looking at this, you can easily see that there are customers who are able to spend around 12,000. I don't know whether it's in US dollars, but I suppose so. Then now with the minimum of 0. So now we can also look on the box plot here. By looking on the box plot for total revenue, you can easily see that the data, it's skewed to the right. So I wanted to explain something very important here. However, even though the data is skewed to the right, there are black marks. If you can just check here, I wanted to explain about this. These are actually examples of outliers. So it shows that in the total revenue of customers, we still have the outliers in the data set. Remember, this is the minimum, this is the lower quartile, this is the quartile 2, this is quartile 3, which is actually 75 percentile. So you can easily see that about 75% of these customers, they roughly spend around 50,000 and below. Yes, no, 4,000, it's 5,000. I apologize, 5,000 and below in terms of their revenue. So you can easily see, but if you look at this, it shows that within this, there are customers who are spending more than around 12,000, which is actually, according to the box plot, this is actually regarded as an outlier. And outliers, sometimes they can affect the analysis of the data, which we will talk about this. Right. Especially when we are going to deal with modeling, the outliers can actually impact the result of the models. Right, let's now proceed. Now I'm going to move on to categorical. Categorical means I'm going to analyze the object, the object, the data set, not the numerical ones. So to do that, it means I'll still do the same. I'll create a function, but we're going to call it count plot. So which will also need the arguments, which will be the data and the item. Still the same thing, plt.figure, the cbon.count. This is just a cbon function to do the bar plot. Count plot the same as the bar plot, also indicating the title, the Y label, and also the rotation, the XT. What does this mean? It means that when we are drawing the box plot, if the item it's kind of like long, we rotate it so that it should be in this form, to be vertical rather than being horizontal, because it will not be visible. Then again, then we apply plt.show. So let's run this function, ladies and gentlemen. Running the function, we're gonna have this. Let's now select the categorical data. I'm still creating the same function, but this time around, I want to select the categorical, not the numerical. So to do that, we can also, let's say, let me try to list them. Categorical data or the categorical column. It will show me that the categorical column or the object, you see, we have gender, we have married, we have seat, we have offer, we have online security, we have payments, method, customer status. Okay, let's say I wanted to only analyze about the customer status or customer reason, and also to display it as a bar or the histogram rather than using that function. Another way would be to do this. Let's say I wanted to say, okay, fine, just an example. Let's say I wanted to display the customer status. In Python, it's either I do it like this. To call that function, I'll say data in quotation marks, then it will be the customer ID. So now to do this, I'll say, okay, fine. Let's say I wanted to know more about this. I'll just say, okay, dot value count. Value count means I want it to count whatever it has in it. So if we run this, you see it shows that we have customers who stayed. It's around 4,720 who stayed, who churned. It's around 1,800, then who joined, it's only 454. But let's say I wanted to show them as, let's say I wanted to show them as a percentage, or let's say I wanted to add them, let's say dot sum, it will tell me all in all, they should be 7,043. But now, how about if I just wanted to normalize them? I'm gonna use a function called normalize. This will only show them as a percentage. Normalize equals to true. So if I do this, means to now round them into percentage. So let's say I wanted to actually know the actual in terms of, let's say round, then let's say I wanted to round to 3 decimal places, then multiply this by 100. So I wanted to multiply them as 100. So you see, it shows that it's only 67% who stayed. The 26 are those that joined, and 6.4% is those ones that, I'm say 6.4 are those customers who joined, and 27% is those who churned. But what if I wanted to show this as a pie chart? A pie chart, there's a function called dot plot. So I can just say dot plot here. So I'll specify the kind here, it's the pie. So I wanted to show it as a pie. And then we'll say, but I'll also put the title. So I can say the title is so I can just say the pie chart, for customer status. Then we have something called auto percentage, PCT, percentage. Okay, but it's okay. This one is just to round the values. So let's run this. It will show a pie chart. Okay, it will show, okay, it means I need to rerun this again. Yes, it's showing a pie chart to say those that are stayed, those that are joined, and those that are changed, but it did not show the value. But we'll look at that. So, but if I wanted Python not to display this, it means I have to put this semicolon here. So let's run it. It will not show those things now. This is another function, but we'll come to that. Let me just do it for now. So here I was just analyzing displaying the customer reasons of chaining, but as a bar plot, but with the horizontal part. So this will be the function. So you see that when we look at this, it's displaying to us that the customer reasons of churning, most of the customers, their reasons of churning is the issue of competitors had better devices or other competitors who are competing with this company have better devices than others. The attitude of the support team, competitor made better offer, and the least is the issue of the deceased, poor expertise of phone support, lack of self-service on website. And again, the competitor offered more data. This is the reasons of the customers churning. We can also look on the, let's call the count plot function to display the customer status. So by so doing, we still have this. It shows, you see that majority are those that stayed. Then we have the customers who churned. But what if I wanted to show them as a percentage? Already I've done that. I've done that to say we can still do this and say I've done that to show as a percentage. So dot value counts, then normalized. By so doing, normalized means to convert that to a percentage. Normalized equals to true, then that is the function. You see, that is what I was saying. You can also round or multiply by 100 to convert them into percentages, because they said as a percentage. So let's say round into, this is the function for rounding. So, and this also, and the NumPy function. So I can also, if I want to do that, I can say np dot, if I can say np dot round, this one the same thing. Remember, there's no need for me to do this because already I've called the NumPy. So maybe I wanted to round to 2 decimal places. Let's just say to 3, then multiply this by 100. Means I'm converting everything to 100. You see, it says, oh, unexpected. What is the problem? Okay, let me check here. Let me check. Okay, the function is there. Okay, it says unexpected. Okay, let me just use np dot round. It's okay. Now, what is the problem? Okay, let's check. Normalize equals to 3. Value count data dot. Okay, let's check this data. Customer status normalize. Okay, let's check this. Okay, unexpected indent. What is the problem here? Okay, let me just try to remove this. Okay, check round. Okay, open the, okay, now I understand. So let me just put another one here and check. Okay. Let's say before adding this, check something. Okay, so it means the problem is here. What is the issue now? Normalize equals to 3 dot value count. Okay. Okay, let me redo this. What is the problem here? Okay. Data dot customer. Let me go and call it like this. What is the problem? Okay. Dot value count. And normalize true. Okay, that is. Then now let's round this round open, then you had 3 decimal places, close, multiply that by 100. So what was the problem actually? Okay, so there it is. Then now, like also we can display this as a pie. Then yeah, I was talking about the auto points, but this applies to only when we want to plot a pie chart. So when we run this, let's run this. It means it will show the values, but it will be rounded to 1 decimal places. So let's close here and run the function. So you see, it has rounded those values. It shows that 67% of the customer stayed, whereas 26.5% have changed and 6.4 just joined the company. So this is what we got in terms of the customer status. And let's move on. When we move on, then we also look at the customer, the churn category. We also will display a pie chart for the churn category. Let's do that. So in terms of this, it shows that majority, 45% of the customers category, they are churning, they are under competitor. So you see that it is based on what I was talking about here, that most are saying the competitors has better devices. That's why they were leaving or they were churning. So this is their category, followed by around 17% is the issue of dissatisfaction. 16.8 is the attitude of the company. The 11.3 is the price, then the list is others. And also we can also display this as a bar graph, the same information, but as a bar graph, but horizontally. So when we say bar graph H, in terms of this, it shows that it will display it as a horizontally. But if we do not show this H here, it will not display that as a horizontal bar graph. It will display it as a vertical. So let me just try to do away with the H. This is a horizontal function. So if I run this, then it will only show the bar graph, but in a horizontal format. Yes, in a vertical format. Just a minute, guys. Oh, this also, when I say in ascending order, it means it will order them from smallest to highest, you can see. But if I say false, ascending order, okay, if I say ascending equals to false, if I say ascending false, it means it will not arrange them in ascending order. Okay, apologize, guys. Oh, okay, there's something that I said there. Oh, the true, okay. Okay, right. You see, it is now arranged from smallest, from highest to smallest. But I can also do this and say, okay, fine. Let's say if I say true, then now I wanted to make it as horizontal. So let's run this. You see, same information that we got here. Where is it that we got here? You see, here it was just a plot, but looking at the chain reason. So this also showing the category to say majority of the customers are churning because of the competitors. And yeah, the list is the issue of others and the price. Let's now display the count plot or the bar plot for the customers by payments of like payment method. We can do that. Let's run it. It shows that the majority of the customers, they're making transaction using bank with withdrawal, followed by credit card, and the list is the mailed check. Then again, we can also display this as a pie chart, same information. Then how about the issue of the type of contract that the customer are having? Like we can also display this as a horizontal bar graph. So it shows that majority are using month to month type of contract, followed by 2 years, and the least it's 1 year. Then we can also look at I think it's the same information as a pie chart. It will still display the same information as a percentage. Now to say only 51% are using month to month, like what I said. Then now we can look at the offer, the count plot for data in terms of the offer. Most of the customers that are using offer option B and E with the list, which is option C. Then we can also display that as a pie chart. And we can also display that. Okay, in terms of the gender, let's now analyze the gender. This is just the categorical. In terms of gender, I'll also display a pie chart for a gender, customers by gender, just to look on majority. Like it shows that around 51% of these customers are males, with, let's just say they are just approximately 50-50. Like, yeah, 50-50. But because if we round this will be 51%. And this will be just around, just around 50-50 actually. Right. Again, we can now move on to the bivariate. Bivariate now, it means we are combining, we are looking at two columns, but I'll first consider the categorical and the numerical. Here, I'll display the box plot for both numerical and categorical, but yes, so this is the function that I've created here. Now, here is just a list of categorical column to be used for visualization. So I just listed those categorical columns that I wanted to use rather than choosing all of them. I'm being specific here. So what I want to do is I want to use something like a for loop to say for any variable that is inside this list, then I have to plot this. Remember, I'm calling my function the box plot to say for any variable that is inside this categorical column. So this is called a for loop. So what it will do, it will say, okay, it will go inside any item in the categorical column. Then it take, if it's gender, it will take it and actually generate it will actually generate the box plot. But yeah, I wanted just to show the one that is in index number 0. So it will be 0, 1. It means this one will show only for merit. But if I say for variable in categorical data, no, I was not supposed to show this. I apologize, because it was taking the information at the back there. Okay, but it's fine. It's okay. It says for any variable that is in the categorical, the column that I listed here. So it will take everything from index 1 and forward, then it will display. Remember this one, if I run this, it will only, or it says the cat is not defined, or I did not run this. Let's run it, then I run this one. Okay, guys, I apologize. You see now it's only showing what is this? Oh, the numerical columns. It's showing the numerical columns with yes, because you're comparing gender and the numerical columns. So you see that in terms of this, the number of dependents relative to merit. So it shows that there's a yes for merit in terms of the number of dependents, and also there's no much information about the no. So even the offer, like the offered information, then again, this is just a box plot for bivariate data. So let's go down, let's run again this one. You see, this one, it will just show the box plot for the latitude relative to merit. Why this? Because it's now we're comparing numerical and categorical. So if you say numerical from 2, it means from 2 from the numerical column. Where is it? If you go back, it will choose from index 2. Okay, it's okay. Let's just proceed now. Then again, if we come down, this is the information for the latitude. Then we can run it again. So actually, I did not want to display all of them. but it was possible to display all of them. But to save time, I do not want to display all of them. Okay, while waiting for the loop to complete. So this one will actually display multiple because it says for variable in CAD, it will use all of them in categorical together with the numerical column from 0. It means if we say numerical column from 0, where is our numerical columns? Okay, let me just go back where I've listed them. Okay, let me just go up. This is the categorical where the numerical columns, it means from 0, it means it will include the age, the number of dependents, all of them. So let's just come down here. So this is the information. It's actually displaying all the box plot of the, like comparing the categorical and the numerical. So you can come down here. I want to show you something. Okay, fine. In terms of gender, in terms of relative to the online security, relative to the device protection, and there's not much information about this. For example, if you look at the number of dependents relative to payment method, the information we have is for credit card with outliers on the right side. For withdrawal and for medical, there's not much information, it's just outliers. Then the issue of comparing the number of dependents relative to customer status, also have the stayed and the churned and the joined. Then this is the information. Actually, it's fine. We can just proceed. Then now in the issue of, here I was just analyzing looking at the categorical data. Okay, just a minute, guys. Yeah, I was just looking at the categorical data only, the bivariate, but for categorical data. Okay, guys. Right, here what I've just created a function to display the categorical data, just to plot the count plot for both the categorical data only. Then let's run this. When we run this, then now here I wanted to display like comparing the box plot for like gender relative to the customer status, like how many in terms of the gender, how many who churned and how many who did not churn. Okay. Let's display this. So you can easily see that, let's look at this. You can easily see that in terms of gender, most female customers are staying, actually, like most female customers are staying compared to those who churned and those who joined. But looking at this, I think they actually have the same number, but I think it's a bit higher than this, but with a small margin. But in terms of churning, they are approximately the same. And also those who just join. Okay, let's just do this. Let's now proceed with the analysis and check in terms of percentages. Right, by looking at this here, I'll just create a function to group the customer status by gender and also display this as a pie chart. Okay, let me just do this. Let me just copy this only before we do display a pie chart. Okay, let's say, let me try to run this. Okay, it says it's showing this as a panda. Oh, okay. Now I understand. Okay. Then now, okay, let's just say normalize. Normalize. Count normalizing. So you see that it shows that in terms of females, it's around 67% who, like females who stayed, who churned, and who just joined. But now in terms of this, in terms of the percentages, let's just try to check something. Let's say I wanted to check right? Normalize equals to false. I want to check something. So you see that it's roughly 2,338 have stayed, whereas male is 2,382. So let's do the summing of this information, which is the same. So you can see that majority actually in like fifth, like in terms of the percentage, they're approximately the same in terms of the customer, in terms of gender, who stayed, who just stayed, but however, who changed, like more females have changed, have changed in compared to the males, but with just 9 as a difference. Then, and only those who just joined, like more females have joined as compared to, I'm saying more males have joined as compared to females. Right, again, we can also display this as a pie chart, ladies and gentlemen. Let's display this as a pie chart. There is the information, but it's not actually well visible. But it becomes easier when we do this. If we do the normalization, if we say normalize equals to true, normalize equals to true, it will just give us a good display. Okay, what is the problem? Okay, it says normalize. I've done equal normalizing. Okay, I've repeated the normalized function, then it says normalized, okay, with the bigger M, not bigger M. So I've told you that Python is it's case sensitive. So this is the percentage. It's still showing the same result here. Let's just compare the offers in like the customer status comparing to their offers. And when we do this, when we run this in terms of their offers, it shows that majority of the customers in terms of their offers, those who stayed, they actually preferred offer B, followed by offer A, and with the least, which is offer E. But in terms of those who churned, the majority of the customers who churned are those who are using offer E. Majority of the customers who churned are those who are using offer E, but with the least in offer A and offer B. Right, then now we can move on to, let's say if we wanted to show this as a percentage, wanted to show this as a percentage and multiply that by 100, still the same function. You see, it shows that around 93%, 93.3% of customers who are using offer A are the ones that churned. You see, I did not arrange this alphabetical because I did not create that, but it's fine. We can continue with that. Followed by 87.7, it's those who are in B. Actually, the B, it says 93.3. 93.3 are those who churned on what? Offer A, using offer A. Oh, okay, offer A is 93.3, or offer A is this one. But why is it having a higher percentage? But when compared to that, it's a different case. Okay, no, it's fine. Then now, or it's because we have made group by, okay, it's fine, so it's okay. Then again, we have to calculate the correlation matrix. Ladies and gentlemen, in terms of the correlation matrix, this actually shows, wanted to analyze the correlation between the two. For example, let's say we have item 1, item 2, item 3, wanted to calculate the correlation between them. Item 1, item 2, item 3. Then in between, this is for correlation between 1 and 1. Actually, the correlation between two items, which are actually the same, is the same as the variance, ladies and gentlemen. So actually, if I were to define this, I'll say the correlation between A and B, it is the covariance between the A and the B divided by the standard deviation for A and the standard deviation for B. But here, when we say the correlation between A and A, this will become the covariance between the A and the A, divide by the standard deviation for A and standard deviation for B. But we know that mathematically, the covariance of the same asset actually is the same as the variance squared, which means here you're going to have the correlation between A and B. This will be the covariance squared. I'm saying the variance squared divided by this will be variance A. I apologize, should be A here. Also variance standard deviation A and A. So this will just be variance squared divided by variance squared, which gives us 1. Which means on the diagonal here, the correlation will be 1 all the time. So, but below that and above that, the correlation will not be 1. So here's the function that we do to actually calculate the correlation matrix of the numerical column. So let's run this. It will display whatever I'm saying now. So, okay, fine. Let's run this function, ladies and gentlemen. So when we run this, it will show that, okay, let me just say compute, display the correlation matrix. I can also say print the matrix. There's no problem with that. You see, look at this. It's showing the correlation between this column. If you look at this, you can easily see that the correlation between age and age, it's 1. This is what I was actually talking about. Why? Because diagonally, this is the correlation between number of dependents and it's 1. Then correlation between latitude and latitude will be 1. Because the correlation between, like the correlation of like between two, between the same asset is the same as the covariance, which is actually giving us 1. That's why it is like this. And remember, it's not about like, it's just showing almost everything, yeah? So this is the correlation matrix, but we need to display these as a heat map. We need to display this as the heat map to actually talk about the strength between two variables. We know that if the correlation is higher, or is like if the correlation is positive, then you're going to have a positive correlation. But if the correlation is negative, we're going to have a negative correlation between the two. And usually if there is a correlation between two variable, we say there's a strong positive correlation or there's a strong negative correlation. However, remember, correlation does not imply causation. So correlation and causation is not the same thing. So when two variable or when two column, when we say they're highly correlated, this does not mean that one atom, like atom A, it is the cause of the other. So it means correlation does not imply causation in statistics. Right, then let's move on with the by computing the heat map. Right, what I've done here is just that you see this is showing the correlation between the two, since we have a lot of data. So we'll try to analyze this. If you look at this data, you can easily see that the majority of these are not highly correlated. It's only if you compare the correlation between total revenue and the total charge, there is a very higher correlation. You see around 97%, 0.97. You see that it shows that there's a very strong positive correlation between total charges and revenue. And another, we can also look at, if you look at the tenure in months and the total charges, also it's around 82% in terms of correlation. We can also check others. So there's a very strong positive correlation between total revenue and total charges. And this does not imply that total revenue is caused by total charges. It just says there's a strong positive correlation. And again, we can also check between the others. For example, total revenue and the long distance the total long distance. And what could be the reason of this very higher correlation is because when looking at the total revenue earlier, when they calculate total revenue, they also used the total charges. In the calculation of total revenue, they use total charges. They also use the total extra charge, the total charges were also included. So these are the reasons why we have a very strong positive correlation. But now let's create a heat map. Already here, I will also select the numerical columns only. Then we're going to use a function called sn.heatmap. This is the function we will use to display this the correlation matrix here. And we're going to say correlation dot, I only want to select the numerical column, then same with the minimum of -1 to 1. Then the point is just to round to 2 decimal places, then tied layout, then run this, and now it will display. But due to my machine, it might not even show the value set. It means I was supposed to set other parameters, but it's fine. I'll explain this. This is the correlation heat map. Remember, I said here, this shows that the correlation is between this is 1. So the correlation between this is actually 1 here, the diagonal. But when we look at this, we are actually comparing the colors. So those that have this around this color, it shows that they're closer to 1. You can easily see that since this one have this color, they have a correlation of 1. But those that have a blue color, they have a correlation of around -1 to approximately -0.7. They have a very low correlation. But how about those that have this kind of like if you look at these ones here, these ones, the correlation is it's around here. It's around 0.25 to 0.50. But let's talk about the total revenue and the total charges. Where is it? I wanted to talk about total revenue and total charges. If you look at the combination between total revenue and total charges, it's here. Total charges, where is it? Yes, total charge. You can easily see that the correlation is a value that is closer to 1. You see, it's around here. Remember, I said it's around 0.972. You see, it's closer to 1. So this is the correlation matrix. We're just looking at comparing the correlation between these variables. Okay. Now let's move on. In the next part here, we're going to do something called the data pre-processing. Here it means you're going to clean the data. We're going to actually look at the features that are unnecessary, which will not make an impact in modeling. So right now, first of all, I'll run this. So we also make a copy of the data. So I've already called it a telecom data. Right, let's display the head of the copied data. We still have the same, the merit, the age, and the offer. You still see that looking at this, we still have the null values, missing values here. We still have missing values. We need to deal with these missing values in the data set. And now the next part, what you're going to do is dealing with missing value. We want to get rid of this, or we want to actually impute them either with the mean or the median, right? So we're going to do this. Let's call this the train columns. I'll just call them the train column. I want to select the categorical data. So now I will impute something called simple imputer. So this is the function in Python that we use to impute missing values with either the median, the mean, or the mode, depending on the type of data set. But you can easily see that from the data, we had things like outliers in some of the data, but there were not that many, which means if we want to impute the numerical columns, we can impute the missing value by using the median. Why the median? Median is actually not affected by outliers. The median is not affected by outliers, unlike the mean. The mean is actually affected by outliers. So if we do the imputation using the mean, the mean will also be affected by outliers. So what I will do is say the median imputer, simple imputer, then missing value, specify that I'm replacing this, the np.none. np.none means this is the NumPy to indicate the null values. To say the strategy that I want to use is to replace those missing values with the median. And this is the function that I actually created. Let's run it without wasting time. So after running, it will show the time it has taken to do the imputation. That's why if we can check in the numerical columns only, you will realize that we no longer have the null values. So let me just run this to confirm to you. Okay, let's just say dot is now dot sum again. So we wanted to show if we still have those missing values. So you see, we no longer have missing values in the numerical columns. So we can now proceed, ladies and gentlemen. Let's now proceed in the next part. So now we're going to do the imputation, but looking at the categorical. So this is a function to select the categorical columns only. So let's run it. It will also do the same. Like, let's now check if we still have the missing values. You see, we no longer have missing values. So it means we have imputed the categorical and the numerical. Remember, in the categorical, we use the mode. The mode, this is the strategy used here is the mode, because remember, when we are dealing with categorical data, you have to use the mode to check the ones that are repeating most frequently. We replace them because we cannot use the mean, because the mean and the median, it's applicable for numerical data. But if you're having the categorical data, you have to use the mode. So we've imputed the missing values using the mode here. I do not want to drop those missing values. So yeah, I've just done the imputation. All right, then now again, we can now check if we still have outliers. So to check the outliers and its treatment, we have to also select the numerical columns only. So I've selected, then this is a function to enumerate those numerical. So it means for those numerical column, it actually gives them numbers. And from there, I have to use the box plot to display, but only showing the 1.5 whiskers to show that I wanted to actually understand to show if we still have the box there. I'm going to say there. Now, outliers. Remember, this has to do with the identification of outliers, where we say quartile 1. I'm saying no, lower fence, where we calculate the lower fence. In statistics, we use quartile 1 minus 1.5 multiplied by the interquartile range, and the upper quartile, which I'm saying upper fence, it will be the upper quartile plus the 1.5 times the interquartile range. So when I say the WIS, it means as a bench, consider this 1.5. So it means this has to do with the identification of outliers. So let's run the function. We run the function now. Running the function, then it will display the numerical columns, actually explain to us that do we have enough outliers or not. It will show everything. If we do not have enough outliers, then it means there is no need to get rid of those outliers. We just have to continue with our analysis. It will take some time. Okay, if you look at this, you can easily see that majority, okay, it's around, okay, if you look at the age has no outliers. The age has no outliers. It's only the number of dependents that has outliers above the whiskers. Then the latitude and longitude, there's no outliers, but the number of referral have outliers at the upper limit, or at the maximum, above the maximum. Then the tenure in months, no outliers here. It has no outliers. Then the average monthly gigabytes has outliers. Then the monthly charge, total Total refund has outliers. Total extra data also has outliers. The long distances charged and the total revenue, but total revenue is just few of them. So which means since majority of the column have no outliers, we can proceed. And beside, you might find that some of these columns might be removed when you are doing the analysis. So since we do not have enough columns, that numerical columns that have outliers, it means we can proceed with the analysis, but we can still trim them. We can still remove the outliers. There's no problem with that. But on my side, I wanted to leave them. Now, remember I said earlier, we need to convert the categorical to numerical. Remember, when you're going to do the analysis, the categorical data need to be converted to numerical, unless if you're going to use some model like the cat boosting, but we'll talk about this later. So what we're going to do, we're going to say with all our data, our categorical column. For example, if you look at our categorical column, most of them, for example, if I say telecom data dot head, I wanted to show you something very important here. The telecom data dot head, you see that columns like gender, the columns are categorical. So it's either we have female and male. So we need to change these to numerical using the program, which means we can say wherever there is female, we can let it to be 0. Wherever there is male, we'll let it to be 1. So we're changing this. We are using what we call the one hot encode or another function. We need to convert so that the computer can be able to model this when we have done it numerical. For example, we can change yes, those who are married to say yes and not married to say 0. So we'll do that using the function. So we want to convert the categorical columns to be numerical. So we want to do that. So, right. So then now we will first run, we'll select the object columns, but we're doing it this several. So here we'll create a function to say, for all the columns that are in this object column, the one that I just selected here. Remember, we can still run this. So it will say for all the columns which are here, it will specify all the column, then it will do, there's a function called factorize. It will convert them from, like, starting with 0, it means it will either change them from with 0 and 1, 2, and so on. For example, if you look on the case of customer status, on the customer status, we have stayed, those who have stayed, those who have changed, those who have joined. What it will do, it will either change this to stage 0, 1, and 2. We'll try to check that. We can also use the one hot encoder. There's no problem with that. So let's run the function now. Let's run this. We're converting to categorical. Let's do head.head. I wanted to display, you see, all of these columns are converted to like using binary numbers, either 0 or 1. You see, gender is either female or male. So if it's female, it's going to be 0, male is going to be 1. Like in the issue of, let's say I wanted to display the unique values for the customer status, okay? So all the columns have been converted. All the categorical columns have been converted to numerical columns in order to do the analysis. Let's go back here. If you look at the customer status, if I can just try to check the unique for customer status, I will say telecom data, and only select the, but I can also say dot customer is also fine. I can also say dot customer status dot unique. So I wanted it to show the unique values only. Okay, maybe I've done, okay, it says there's no object called customer status. Okay, let's just do this. telecom data column. I wanted to show all the columns which are here, but let's try to list it. Let's do the listing, ladies and gentlemen, list. And then so that we're able, okay. So I only want this. Where is this customer status? Oh, okay, I'm supposed to say customer status. Okay. Okay, customer status. Okay, that's fine. Okay, let me just use this. Oh, okay, that's okay. I understand what I'm supposed to have done. Okay. Okay. Oh, sorry. Should have not used the dot there. It is no attribute unique. Okay, fine. Oh, sorry. Unique. The typing, case sensitive. You see, it shows that it has converted 0 for stayed, 1 for churned, 2 for joined. So we know that for 0 it's stayed, 1 is for churned, 2 is for joined. All right, let's now do the same. Now we're gonna select. What is this now? Okay, fine. Here we'll just but already since we have selected the categorical, now we do the same for categorical. Let's do the same, but we have done it already, or we have converted it. Okay, fine. Let's just do the selection of those categorical columns. Okay, let me just get rid of this. Then let's create, well, we are creating a data frame for only categorical. Okay, now, yeah, it means we want to like check on those that are necessary. But now, first of all, yep, since we are using the customer, so you see, I've created a list for those, the categorical columns only. I want to do an analysis for the categorical column only. But however, when you're doing this analysis, I wanted to check which are more important in like the categorical, but we must drop the customer status. Why? Because this is the target variable. It's the one that we want to actually predict. So I want to predict the customer status. So well, first of all, I will drop it from the XCAD data. So to do that, I'll drop it, not for good, but just to do the analysis. Then I will also create the Y data. I will take that customer status as my target variable and create it as the Y data. Actually, I wanted to perform a chi-squared analysis. Then from there, I will have to do scaling. I will have to scale this data from with values like that using a standard scaler. This standard scaler here. It means what it does, it takes the data with the mean and divide by the standard deviation. So it's actually, the values will be between 0 and, let's say, between -1 and 1. So right, then now let's do the analysis by using, but in other parts, somebody can use the min max scaler rather than using a standard scaler. Right, then now let's do the transformation. It means we're normalizing. This has to do with normalization. Then after normalizing, I wanted to also display the first. You see, it has normalized this with values that are okay. No. This is the XCAD data here. It is the first one. Is this? But if I wanted to show this one, it would no longer be shown as the head. Okay, it's fine. Let me just copy this. I want to check something. Okay, let's say we have this. Let's call this the X cat one head, but I don't think it will display that. Okay, you see, it says it because now it is it's no longer a data frame. It's now I think it's a Panda series. Let's do the type. I wanted you to know the type of this data. You see, so it's a non-pi. It's a non-pi array. Okay, so it means if it's a non-pi array, I can just say x dot cat one. Let's just print this. It will just show you. You see now it has normalized the data from like between -1 and 1. So this is the normalization criteria. And another thing one can do is if you want to check like what you can just try to calculate. Let's say you wanted to calculate the mean of this data. It's just an example. You can just say mean of the data, or it's calculating the mean of each. Okay, let's say that sum. It's gonna sum all of this. You see, it's around that. Okay, fine. And then now, so this is a function for numpy. So we're gonna use something called chi-squared actually to calculate, to compute the scores on each, like you're looking at each categorical column comparing with the target variable. So this is the function. Say, let's say I wanted to display the scores. So I'm going to say chi-score scores. Then to do that, it means now I'm going to do this. Okay, it says, oh, okay, fine. Chi-score, what is the reason? It says chi-score is not defined. What is the reason here? Oh, okay, I do not make it as an underscore. Okay, should be an underscore. Apologize. Right, you see, this is showing the chi-squared calculation. Actually, here we have to display this and display the graph to actually look at the importance of, like, to identify the categorical features that are important for predicting the target variable. So we'll arrange this. We're gonna sort the values and we do the ascending false. Why? Because we wanted to start with the highest and start with the lowest. So I'm gonna run this. So this will actually explain to us which are of those categorical columns are actually important to predict the target variable, to predict the customer status. Things like gender, phone services, contract, online backup, offers, married, security online, they have no impact, they have no influence in customer status, as whether they are stayed, they changed or whatever. So which means the only three factors that can affect the customer status is the churn reasoning, their city, where they're coming from, and the churn category, which means within this, like what I just stated there to say, it's only the churn reasoning, the churn category, the city, and a bit of internet service and the other, but majority have no influence. They don't have no influence towards the target variable, which is a customer churn. That's what I said. The churn reason setting are the important categories. So the higher the score, the higher the importance of the future to the category. So it means, therefore, we need to drop the other columns from both the training and the testing. So it means that these have no influence in the analysis. So we must drop them. So looking at this is just a function that I've created to drop the column. Like I have to drop from gender, married, you can see the married also need to be dropped, offers, phone services, everything except, it means in the categorical, I will have to drop all the columns except the chain reasoning city and chain category because they will not have any impact in modeling. Okay, fine. First of all, I'm gonna call the crop. Then now from the original data, I'm gonna drop all the columns. This is the function to drop. I've dropped. Then now you can say data the head. You see that we no longer have gender as the column. We no longer have married. Phone status are no longer there. So it means this is the only data we only have. So it means we can use this to do the analysis. Now to do this, we know, remember I said when we are doing the analysis, we need to split the data into training and testing. This has to do with, we're avoiding something called data leakage. We're avoiding something called data leakage. And this is a good practice for data analysis to split the data into training and testing. Actually, in reality, the data should be split in 3 ways. Should be split in training, testing, and what is called the validation. Actually, the validation should be the second one, then the last one is testing. But since we do not have enough data, we'll only split into train and testing. All right, what I'll do is I'll only say do this also. Okay, fine. Since here our target variable, remember I said this is an example of a classification model, which means my target variable here would be the customer status. This is my target variable, so I'll call it the Y data. So it means the other one, this will be the independent variable. Is the independent, because we want to do the prediction. And to do that means to have the X data, I'll only drop the customer status because it's the one that we're looking at. It is the target variable. Then this side I will create a list of, we actually create the data frame for the Y data, actually is a pandas series. So to do that, let's run this. We'll run this. Then again, we need to split the data into train and testing, but using what you call 30%. What does this mean? 30% as a test size means 70% is the training and 30% is the testing. So it means we're going to split both the X data and the Y. So it's going to be X train, X test, Y train, Y test, using the train test split, the one we just specified earlier. So this is the X data and the Y, then we're going to random. It means now we're setting the random state to be any variable. Here we just used 42. Then now let's do the running of the data. It means here we are splitting the training and the data into 70:30. So 70% is the training, 30% is the testing. So let's do the running. So we are running now. And after running, let's check the data, like the shapes in terms of the sizes. What do we have in the training and what do we have in the testing? So when we look at this, we can easily see that around 49,070 rows and 17 columns are in the training, whereas those that are in testing, it's only 2,113 rows and 17 columns. And to prove this, remember the testing, remember I said it's only what? It's only 70%. So let's just say, let me just take this. I'm taking this and divide this by the telecom data shape, but I wanted the rows only. So we're going to multiply that by 100. So let's multiply that by 100. And we can also round that. Let's say np.round. np.round. We're rounding that to, let's say, 2 decimal places. and multiply that by 100. So let's do that. You can only see that only 30% of the data falls under what is this? The testing. But if we say a dot train, it will only show 70% to show that we have split the data into 30, 70 is to 30. I believe you're following now. Now, remember the issue of normalizing there. We're just normalizing in order to calculate the chi-squared scores actually. But we do not normalize in the original data. So now we must do the normalization both in the training and in the testing. But the normalization is applicable for the independent variable. We cannot normalize for the dependent because already the numbers are between 0 and 1. So let's do the analysis. Then now let's convert this, because after transforming this now NumPy arrays, then now we need to convert them into the Panda frame. So I'm going to say X train 1 equals to PD dot the data frame. Then the X train, the ones that we transform, then now we're going to set them as the data frame. Let's display this. This will be X train 1 dot head. Then it will show us the data as a, you see, it has transformed the data between, like with values that are between -1 and 1, but here majority around 0.5, negative 0.5, and so forth, right? So now we're gonna do the modeling. Remember guys, I said this is an example of a classification model. It's a supervised learning technique. So let me talk about this. Supervised learning technique. Under supervised learning, we have two types of methods. We have what you call the classification, and we have what you call the regression. In terms of regression, it's where we have the inputs and also the output. Actually, in terms of supervised, we have both the input and the outputs. We know the inputs and we also know the output. But now, this we call them the labeling. But in terms of classification, it's where the output are actually binary. Binary, it means either we have yes or no, or 0 is to 1. So we're dealing with binary as an example of classification. But in terms of regression, we're having where actually the output is just a value. For example, if you want to do the price prediction, or yes, the price means we have the inputs together with the value of the price. So we just have one value. So this is an example of a regression. They're both labeled, but with this one, it has to do with binary information. Right. The reason we say this is an example of a classification means whatever I want to do the prediction, instead of the customer status, we either have the following: the status of customers, it's either they stayed, or they churned, or they joined. So you see that this is an example of the binary. So we said it's the 0 state, 1 is it's churned, 2 it's what? Joined. So this is an example of a binary set. And the binary set has to do with classification. This is an example of multi-classification, multi-label classification. So this is an example of a multi-label classification. And when we're dealing with classification, guys, the measures of performance, we use the following. We use something called accuracy. We use something called recall. We use something called precision. We use something called F1 score. This is actually for classification. It's the performance measures that are used for classification only, not for regression. In regression, actually, I think in terms of what I said there, regression has to do with the mean squared errors, the mean absolute errors. These are the method that we use when we are calculating, for example, the R squared score, the R squared score and the R squared adjusted. So this has to do with regression. But however, this is an example of a classification model because we are dealing with binary outcomes. So here we're going to talk about this. We'll first look at what I've said. Remember, I said in terms of this, we have something called accuracy, and followed by recall, followed by precision, followed by precision, okay, precision, followed by F1 score. Right, let me talk about these things. Before I talk about this, let me explain how these things work. Actually, we are comparing whatever the model will be predicting for us and what we know in reality. For example, if we say, let me do this. Let me say just something. Let's say here it is in terms of the model. We are comparing the model, and we are comparing the reality part of it. So I'm gonna do something like this, okay? So here I will just say, okay, let's say this side, I'm gonna call it the true value. Okay, let me just use. So I'll just say it's either is true or it's false or true or false. Sometimes they call it the positives and the negatives, and also the positives and the negative. What does this mean? It means that when we look at this, we're gonna say, the first one, it says we have something called true positive. What is a true positive? True positive occurs when the model predict a customer churning. There's a customer churning. Yes, the customer is churning, but in reality, the customer became a what? A churn. So it means this is called a true positive. So this means the model predicted positive, but in reality, there was a churning. So this is called a true positive. But wherever we have something called false positive, what does this mean? It means the customer, listen to me very well, the model predicted that the customer has changed. The model predicted, the model predicted that the customer has changed. But in reality, the customer has not changed. So this is called a false positive. So we have a false positive. But what is a false negative? A false negative occurs when the model predicts no churning. The model predicts that there is no churning, but in reality, there is a churn. So it means this is called a false, it's a false negative. It's a false negative because the model predicted that there is no churning, but in reality, there is a churning. So this is a false negative. And again, what is a false, what is a true negative? A true negative predict that no customer is churning, and in reality, there's no churning. This is the true negative. But now, there's something we need to understand here. Particularly the true positive and true negatives, they are fine because if the customer has predicted that there will be churning and in reality there's a churning, then it's fine. But how about if the model predict that there's churning, but in reality there's no churning? So this is a false positive. And how about if the model predicted that there is no churning, but in reality there's a what? A churning. So this is a false negative. So this is what we need to minimize. We need to minimize both the false positive and false negative. Right. Then in terms of accuracy, let me explain how accuracy works. Accuracy, we add the total, the true positive. So it means it is the true positive plus the true negative divided by everything. So it will be true positive plus true negative plus false positive plus false negative. But let's talk about the recall. With the recall, we only consider the true positive in relation to the reality. So this will be true positive plus false, no, true positive divided by true positive plus the false negative, which means here this one has to do with minimizing. The recall has to minimize the false negative, whereas the precision minimize the true negative. So it means here we're gonna say no. It minimizes the false positive, so it will be the false. No, I think there's a typo here. Okay, this should be the true positive divided by the true positive plus the false positive, which means this one minimizes the precision, minimizes the false positive. However, in terms of the F1 score, F1 score minimizes both the false negative and false positive, which is the harmonic mean is 2 times the recall, is 2 times the recall times the precision divided by the sum of the recall plus the precision. So this is called a harmonic. Actually, this is good when we are dealing with imbalanced data. If we have imbalanced data, then F1 score is the better one. But since here usually the F1 score is much better because it minimizes both the false and the false negative and false positive, and the higher the score, the better it is. Unlike the recall and the accuracy and the issue of precision, but we'll use them interchangeably using what you call the confusion matrix. Right, let's now do the modeling. All right, in terms of our modeling, ladies and gentlemen, I'll only consider the classification models, machine learning models, such as the random forest classifier and the others, which you'll see them next. Then here I would define a model to actually calculate the performance, the model performance classification using what I was just saying now. So initially from here, I'll just go through it. So it define the model performance classification from sklearn. Here it needs the model. It means the model and the predictors and also the target, what do you actually want. And first it will be prediction is the model dot predict, just to predict using the predictors, calculate the accuracy score, calculate the recall score, calculate the precision score, calculate the F1 score, but using what you call the weighted, because this is an example of a multi-classification. Then I'm going to display this as a data frame of those the accuracy. So what we have done here, we have used what you call the dictionary. So to display the result of the accuracy using the key value. So this is the key and the value pair using what you call a dictionary, which I'll talk about it in the next video. Which a dictionary, it's one of the Python function that we use to represent values. It needs the key and the value pair. So here it means we are specifying the accuracy and its value, the weighted recall and its value, just like that, as an as a data frame using the dictionaries. So dictionaries and lists are very important in Python. All right, ladies and gentlemen, let's do the running here. When we run the model here, let's display what is gonna it will just show that everything's fine. But since here we want to use the F1 score and the make score from the sklearn matrix, so let's just run it. Our scorer here, we're going to use the weighted average of the F1 scores. So let's do the running. So now I'm going to build the model. I'm going to call what you call the logistic regression, the decision classifier, the other boost, the gradient boost classifier, the random classifier. These are example of ensemble models, and also use what you call the k-neighbor classification and the support vector classification. Then here I'll also create a list. Let me say a dictionary of those models, then in order to use what you call the cross validation score. Did I get rid of the validation score there? Let's check. It is the validation score is there. So let's now go down and do the running. Okay, let's do the modeling. Right, when we run here, it will have the following. Okay, let's just explain. Okay, now we can run the models. So we're going to use something called cross validation. Then let's run here. It will show the results of each model in terms of the mean of the F1 scores. However, it will take some time, guys. Let's just wait for it. Estimate a model. Yeah, now it has calculated the F1 score for logistic regression. It says it's 95%. K-neighbor, it's 85%. Then decision tree, it's 93. You see, the model is performing well when we're using cross-validation. Randoms, forest, bagging, these are ensemble learning models. Then it has to come to the gradient boosting, the other boosting, and the support vector matching. So it will take some time, but here it's actually displaying the F1 score. The reason here I'm using F1 score because the F1 score, it is the harmonic mean of the recall and precision, which actually minimize both the the false negative and the false positive. So now it's still running. Then while it's still running here, I will just check the performance for each model. Then I'm gonna call that function that we created here for the model performance. Then from here, I will call each model using the dictionary, but yet will be model.key value. So you see, I'm using this is the key value. The key value it will bring the value there. This is the key, using the key only. Model.key, model.key, then here it will only calculate the scores, performance scores, but using the trained data set. Let's just wait. Okay, now it has calculated using the cross validation. Let's now calculate the performance for each model, the logistic regression, K-neighbor, decision tree, random forest, bagging, gradient, other boost. We actually wanted to compare their models actually. While still running, ladies and gentlemen, let me explain something called overfitting and underfitting. All right, what do we mean by something called overfitting? Overfitting and underfitting are these techniques which actually affect the model performance. The model that is actually overfitting, it is the model that performed better or it performed good in the training. But when it comes to the testing, it performed poorly. So it is good in the training, but in the testing data, it performs poorly. So this is an example of an overfitting. And overfitting is actually a problem when you are doing the modeling. Right. Again, the issue of underfitting. Underfitting is just a model that performed poorly in both training and testing. It performed poorly in both the training and the testing. That is an example of an underfitting. We need to avoid this when we are doing the analysis. We must avoid overfitting and we must also avoid underfitting when we're doing the analysis. Okay, now it has computed the performance. Now let's display the result for the training only. You can easily see that when you look at the trend, remember we are actually interested on the weighted, the F1 scores, because remember it said it minimized both the the training, and like it minimizes both the false negative and false positive. If you look at this, let's look at the logistic regression. Under logistic regression, the accuracy is 95%, weighted recall is 95, then weighted precision is 95, whereas weighted F1 score is also 95. But when you look at this, the random forest is exactly 1. This might be the issue of overfitting, because if it's just giving us exact accuracy with 100%, I believe something might be wrong, but there's no problem with that. Let's also look at in terms of the weighted average, the weighted F1 score, which model has the highest value. It's begging, followed by gradient boosting, followed by the other boost. Yes, yeah, other boost and logistic, and also the neighbors. Neighbor, but now we cannot say anything about this because we need to compare the result in terms of the training and testing to check if we still have overfitting or not. So let's do the running now. I'm gonna compute this. I'm gonna compute the result of the training. Let's compute the result of the testing. I'm just saying, even though it will take some time. Let's compare the result of the testing. Okay, it has calculated the performance. Then let's display that. Now you see we are comparing the testing and training. Let's look at the performance here. You can easily see that begging it's here has the highest F1 score in the testing, and also in the training it's performed. You see, it has 99.5%. Now it is at 99.6. You see, that is not actually overfitting. It's performing good in the training, and it's also performing good in the testing. And again, if you look at the gradient boosting, it was 97.6% in the training. Now it's 98.3. It's also performing good. There's no overfitting issue. Then how about the other boost? 95.6 in the training and 95.0 in the testing. So it's a small decrease. And also support vector machine is 93.9 in the testing, and now it's 92.5 in the training. You see that there's a drop, which means it might be affected by an overfitting, slightly so. So which means you can easily see that is between begging and gradient boosting, which actually perform. Even the random forest and also the decision tree. But let's look at the K neighbor. K neighbor is performing, it was at 90.4% in the testing, I'm saying in the training. Now it is 87 points. So you see that is performing well in the training. So in the testing, which is an example of overfitting. However, when we look at this, we can easily see that if we play around the begging and the gradient, this will be the best models in terms of the analysis. But let's just try to perform the hyper-parametric tuning using the gradient boosting classifier, using what you call a random search. Random search actually generate, like, look at the performance or give us the optimal parameters that we can use to get the best model, but not like randomly picking, looking at the number of estimators, the learning rate, and the sample, and also the maximum features. These are the features behind gradient boosting. So let's do the hyper-parametric tuning just to look at the performance, ladies and gentlemen. It will take some time. It will just take some time. I believe you are following. I think you are now you understand what you mean by when the model overfit and when the model underfit. So these are the things that we need to avoid when we are doing data, when we are performing data analysis. Okay, it will just take some time. Let's just wait a minute, then from there we'll actually try to do what you call the performance. We'll look at the performance for that tuned model. We look at the performance for that tuned model for the gradient, then looking at the X train and Y train. Then from there, we can also look in the performance in the testing data. Remember, this has to do with training, and this also has to do with testing to compare the result. I think it will be displayed soon. Then again, we can display the result, both of them, and using what you call the concat function. Concat means combining the result. Let me, while waiting for the output, look at this. Here we're going to predict, we're going to look at the performance for the training only. Here we look for the performance for the testing. Then here we're going to use something called concat. Concat is just a way to combine two data frame. So we're going to be pd.concat. So we are concating this result and this result, but as the columns. Then from there, we'll have to actually include when labeling, you're going to say performance on the G boost equals to, we're creating a list of to say we need the result of the performance of the training and the result of the testing. Then we display or we print the result of that tuned model. We just want to check if there's any improvement. However, if there is no any improvement, then we have to stick to the original performance that we got earlier. So it will just take some time, ladies and gentlemen. But I think soon it will give us the results. So let's go back to our, while still making the print, the results. Let's go and look at what, like in terms of the customer status. Customer status, we've seen that around, and actually this is an example of an imbalanced data set, because actually when you look at the customer status, it would actually favors those who actually stayed as compared to the churn, and because of the weight, you can easily see that 67% of the customers have stayed, whereas 27% has churned and 6.4 has joined. So we want to come up with the prediction, but this has to do with the imbalanced data. And since it's an imbalanced data, it means we have to do something called oversampling and under sampling. But just to minimize this, ladies and gentlemen, let's check if it has already given the results. Okay, just a minute. Hyper-parametric is still computing. It will just take. So let me check at the cross validation. It's 5. Okay, so it means soon it will give us the results. Then from here, we have to come up with the future importance to look on. According to the model, what does the model says about the important future in customer status in terms of those who the customers who stayed and the customers who churned and those who joined. And after that, we'll make the prediction. Okay, guys, I think there is wind outside, but let's just proceed. Okay. The random search CV, it's actually better than that of the grid, because with the grid means it will move in every iteration. Because when we say np.range, it means we are ranging these values from 100 to 150, but with an increment of 25. So it will move from 100 to 125, 125 to 150, just like that. So it will actually use 3 values. But here, in terms of the learning rate, we only use 0.1, 0.05, and 1. Then the sample only use 0.5, and because this is just a list. Then the max futures we just listed between, like we list values, like we're using 0.5 and 0.3. So what we'll do, it will just use those outcomes, then it will randomly select them. Unlike when we use grid search. With the grid search, it means it will first use, for example, it will first use, is this an example? It will first use 100 with a learning rate of 0.2, 100 with a learning rate of 0.05, just like that, 100 with the learning rate of 1. But using the combination of this the subsamples and the maximum futures. But with this one, it is just choosing randomly. So I'm surprised when it's taking time. It should have given us the results soon. But it's fine. Let's just give it some time. This is just a function to calculate, to estimate, like to list the best combination of parameters that will give us the best results. This is to check whether there's an improvement or not. Hyper-parametric tuning. It is taking time. Okay, let's just wait for it for a minute. Okay, actually I was supposed to reduce the parameter, but it's fine. Let's just leave it to give the outputs. Okay, now it's still showing. Yeah, it shows that the best, like the optimal, the best combination of parameter here, the learning rate should be 0.5, the max futures should be 0.5. Number of estimators is 125 stays, like sample will be 0.5. So, okay, let's do the running. Let's do the output here. Performance matrix for both. So now it will be displayed. You see, it shows that when you look at this, in terms of the accuracy of the gradient boosting, the gradient boosting in the training, it gives it's 96.6, but in the testing, it's 95.3. There's a slight decline. But in terms of recall also it has declined, but precision also it has declined. But when you look at F1 score, because this minimizes both the false negative and false positive, it has declined, but with just a small margin. I think around, yeah, with just a small margin. You can see that there's a slight overfitting, but not that much. But we can even rely on this when we are doing the analysis, because it's not a huge decline. But remember, the F1 score minimizes both the recall and I'm saying both the false negative and false positive. So let's now display the future importance on the best model to actually look on which features are important in making predictions of the customer status. So let's do the display using that tuned model. You can easily see that the most important features in customer chaining has to do with customer reason, the reason of chaining, the tenure in months, the chain category, total revenue, total charges, monthly charges. But with the list, the least being the total extra charges, total refund, number of dependents, longitude, attitude, I apologize, latitude, the average monthly long distances, average monthly gigabytes, city age. This has no impact in customer chaining status in terms of their prediction. So it means the first five most is the churn reasons, the tenure in months, churn category, total revenue, and total charges. Then now, which means that we can now make the prediction. Let's make the prediction. So I'm gonna set this as the pandas series. Then let's do the counting. The counting, it shows that around 1,466 have stayed in terms of the will stay in terms of the prediction, but 467 will churn, and around 180 will join. But now let's display this as a pie chart to do the analysis. This is in terms of the prediction. You see that in terms of the prediction is predicting 69% of the customer they will stay, whereas 22% of the customer will churn, and 8.5% of the customers will join the company. So you can easily see that in terms of the information we had before, it was only 67% of the customers who stayed in the company, in the telecom company, whereas 20 no yes, whereas 26.7% are those who churned, 6.4 have joined. So you see now that there's a decrease in the number of customers who churned. From 27%, the model is predicting only what is the model is only predicting it's predicting 22% who will churn, whereas you see from 6.4, the model is only estimating around 8.5% of the customer will join, whereas 69% of the customer will stay, and only 22% of the customer will churn. So this is the predicted result. So as an insight or recommendation, we'll say the telecom consists of 7,000 rows, 7,043 rows and 38 columns, what we have seen. But several classification models were used to predict the factors that can affect customer chaining. You have seen we use a gradient boosting, logistic, support vector machines. And again, we found that the gradient boosting model, it's one of, it means we have seen that even the bagging, it's one of the models that is used to predict the customer chaining and its major driving forces of chaining. To evaluate the model performance, we trained and tested the dataset to predict customer chaining, where we split it to 70 into training and 30 into testing, which is actually a good practice, but in other instances, you can use 60 to 40. Then, according to the gradient boost classification, the first 5 most driving forces of customer chaining are the reasons of customers to churn, the tenure in months, the churn category, and the total revenue, and also the total charges charged by the company. So this is what I actually got in this data set. I believe you are following, ladies and gentlemen, and I strongly believe you enjoyed. Thank you very much. Bye-bye.